But what are those chapters? Small chapters or big chapters? Small chapters, I guess.
Small chapters, I think 14, 13 pages.
14, 13 pages chapters, yeah. Second term portion, so I am also not worried about you guys second term portion, but first term portion mostly about organic chemistry, because there is a lot of chemistry in, sorry, there is a lot of organic chemistry in your standard 12. Okay, so I was talking about that we'll start with the reaction. Okay, so we have CH3, and let us say that we have one more CH3 like this, or let us say CH molecule here, which is attached to a bromine molecule here, and there is a CH3. Okay, and I react this with aqueous NaOH. Okay, NaOH that is dissolved in water. What I see is that the CH3, CH, CH3, these things are unchanged, but the Br has been replaced by OH. And Br is replaced by OH, and there is a byproduct which is NABr, Okay, so these are the reactants, and that is those are the products. You understand this much, right? Okay, now let us see what is happening here. So whenever we start some reaction, we start with what bonds are broken, right? Because first of all, the CBr bond would have been broken, and then only COH bond would have been formed. Yes or no?
Yes, sir.
So the first step would be the CBr bond is broken, right? We are writing just the changes. Okay, what has changed here? So we said that the Br has been replaced by OH. Now we are investigating in a bit deeper sense in terms of bond. So we are saying that CBr bond is broken. Okay, CBr bond is broken. Now we are more interested in the bonds which are broken. Okay, we are more interested in some bonds which are broken. Why? Because breaking of bond, it needs some kind of energy. Okay, it needs some kind of energy. You are removing apart, you're tearing apart two things which have been attracted and which have been combined through a chemical bond. So we'll start our lesson with the breaking of bonds. Okay, with the breaking of bonds. So we'll see what happens when bonds break. So we'll say that breaking of bond. Huh? You want to learn about the breaking of bonds. What is a bond? Bond is, in organic chemistry, there's a shared pair of electrons, right? So what is bond? Let me just revisit bond. What is bond? Shared pair of electrons, right? Shared pair of electrons. Now the breaking of bond, it can happen, let us say, we have A, which is attached to B, okay? And then we can say A and B, okay? Now we can show this as the Lewis dot structure, that one pair of electron has been shared between these atoms. Now there are two things can happen when I want to break this bond. Either both of these electrons can move to the atom B, okay, or A, okay, and we can say that A, it is losing an electron, that is why A positive, plus B, which is gaining electron. So we'll write B negative. B will be gaining a negative charge. Similarly, in this case, and another case that can happen here is one electron moves to B and the other electron moves to A. And what do we get? We get A free radical and B with its own electron. And because one of the electrons would be of the A atom and the other electron would be of the B atom, because they are sharing electrons, right? So B is sharing with A is sharing one electron with B. Now in this case, what is happening? Both of them are getting their respective electrons. A is getting its electron and B is getting its electron, and when they are having those two electrons and the bond has been broken. Okay, the bond has been broken. They are no more sharing the pair of electrons. They are no more sharing the pair. Here's something else is happening. What is happening here in this case? In this case, the B is taking both of the electrons. Okay, so B, let us say that this red electron was of A, okay, and the black electron was of B. So let me also say here. Okay, now in this case, the B, it has, sorry, in this case, A has lost its electron, and the B, it has one of the electrons from A. That is why it has gained an electron, and hence it is a negative charge. Hence it has a negative charge. Now, this A here, it is not in stable state, right? It is not in stable state. We will say that it needs some electron, right? Because it is positively charged. What it will do with electron? It will attract an electron. Okay, so A has tendency to attract electron. And what about B negative? What about B negative? B negative has a tendency to rather I should not write it, has a very long tendency to share electrons to form bond. Because it has charge, and charge is bad. Okay, charge is bad. What about these guys, A and B? So both of these are what? They initially had bond and then they were stable, but now both of them are electron deficient. Okay, so they need electrons. So A also need one electron and it will be stable. B also need one electron and it will be stable. So both of these are what? Electron deficient. Okay, now these which have tendency to attract electron, they are known as electrophile. Okay, and anything which has a tendency to share electrons to form bond, these are known as nucleophile, because they want to form bond, they want to give the electron to a nucleus, okay, to an atom. Hence they are known as nucleophile. Nucleus loving. These are electrons loving. That means they are negatively charged loving species, so they love the negative charge. The nucleophiles, they love the positive charge, because in nucleus we have a positive charge. Okay, and generally nucleus will be electrophile will be electron poor, which are also known as electron sinks. And that means there you will dump the electrons. The electrons will be dumped in the sink. Okay, electron sink. Now nucleophiles are electron rich, and they are also known as electron sources. Where we will be having the sources of electron. Okay, sources of electron. So please write these 2 points and see, when you are having a cleavage, in which both the electrons are going to one particular atom, this is known as heterolytic fission of bond. And when one electron is going to each of the atoms, each of the combined atoms, these are known as homolytic cleavage. Homolytic fission. Okay, in this case, heterolytic fission, let me add one more point. The electron in heterolytic fission of bond, the electron pair is taken by the more electronegative atom. Secondly, for homolytic cleavage, or fission, we use one of the following. Okay, so either you will be using heat or you will be using electricity for homolytic fission, heat, electricity, light, okay, or we will be using peroxide. Okay, so heat is shown by delta sign, electricity is just electricity written, light is shown by h nu, because h nu is what? It means there is some photons there, okay, there is some light there, electromagnetic radiation. Peroxide is generally shown as ROOR. So there will be two oxygens and there will be two other elements, okay, two oxygen and two other atoms or elements or groups. So you can combine these as H, E, L and PER, okay. So you remember this mnemonic of helper. Whenever you see helper, what you will be doing? You will be doing homolytic fission. And if the helper is not there, then what you will be doing? You will be doing a heterolytic fission, okay, a heterolytic fission, and which you have to see that the more electronegative element, it will be getting the electron pair, okay. The electron pair will be taken by more electronegative element. Wait a second, let me reshare this thing. Right till here, let me know if you're done. Done, guys? Okay. Now, once again, let us write here, Anna. You must have forgotten the order of electronegativity. Order of electronegativity of atoms. Okay. So the most electronegative is fluorine, followed by oxygen, nitrogen, chlorine, bromine, iodine, sulfur, carbon, phosphorus, and then hydrogen. So how will you remember this? So this will be phone. This will be, okay, maybe you're not very much phone kal. Remember this as Bihari. This will be Ishq. This will be Pyar. Ishq क्या है? Ishq प्यार है ना? Phone kal Bihari, Ishq प्यार है. Okay, so you try to memorize this sentence. Phone kal Bihari, Ishq प्यार है. Say it 10 times, then you will be remembering the order of electronegativity. Okay, two more points. Okay, two more points regarding the arrows. Arrows, or rather curly arrows. Curly arrows in ORM, organic reaction mechanism. Okay, curly arrows in organic reaction mechanism. Number one, transfer of, or movement, I should say, movement of an electron pair. And that means how many electrons? 2 electrons is shown by double-headed arrow. Okay, like this. Movement of an electron pair is shown by double-headed arrow. Second, I mean, this is important. Okay, I mean this side or that side, that is not very much important. So double-headed arrow. Secondly, movement of an electron. That means one electron is shown by single-headed arrow. Okay, so you will either have like this or like this. So these are what? Single-headed arrow. Next point. So you have arrow like this. So this is your tail of arrow, and this is the head of arrow. Okay, tail of arrow and head of arrow. Now remember that tail originates from, or rather I should say like this. tail should be at an electron source or electron source, okay, at electron source, and the head of arrow should point at an atom. Should point at an atom. So important thing is, what are electron sources? Hai? What are the electron sources? Wait a second, let me reshare. Why is this happening? Yeah, have you written these things? Can I scroll down? Tell me, guys.
Yes, sir.
Okay. So first of all, the electron sources, okay? Electron sources. So electron source, first of all, it will be a lone pair. Okay, a lone pair is what? An electron source. So you will always see that the arrow should be originating either from the lone pair. Okay, so it will never be like the head of the arrow is here. Okay, so you'll be doing it like this. Secondly, what can be electron source? If you have a triple bond, if you have a triple bond, then the electron will be going away from the triple bond. Okay, this is the flow of arrow. How will you be showing? So this is, see, this particular tail, it is pointing towards the electron. It is not pointing towards the atom. Okay, it is not pointing towards the atom. It is pointing towards what? It is pointing towards a bond or a lone pair. Okay, so electrons. It is pointing towards electron. Electron source should be always some electron. Either it is present in lone pair, multiple bond. You can also have X double bond Y. Okay, you can also have X single bond Y, and all of these would be giving electrons. Okay, so the tail should be at a bond. Similarly, you can have some electron sinks. Electron sink. Okay, now an electron sink could be an X atom. Now it has how many electrons? It has 3 bonds. That means it has 6 electrons. Okay, it has 6 electrons. So hence this is what it is: electron poor. It is not stable, right? The shell has not been filled. So this is electron poor, and that is, it is electron sink. And that is why the electron should be coming from something, and it will be pointing towards the X atom. It should be pointing towards the X atom. Similarly, if I have X and Y, and I am seeing that this electron is moving from here to here, that means what? Y is more electronegative. Y is more electronegative. No? So electronegativity sign is chi. Y is more electronegative. Similarly, you can also have sometimes X with a positive sign. So when you have X with a positive sign, but remember that this should be electron poor. Okay, it should not be electron rich. You can also have positive charge when something is electron rich. Okay, so it is just it is not a formal charge, it is a real charge, but it's a positive charge. That means it is electron poor. Similarly, you can have X double bond Y, and in this case, the double bond is pointing towards Y. That means the electron source is what? Let me just do a second. Electron source is the double bond, and Y is the atom which is receiving the electron. Okay, write this down. Let me know if you're done. Okay, we write one more point, that is every curved arrow represents formation and or breaking of bond. Rather, wait a second. I should rather say in the opposite direction, that it represents breaking and or. So breaking, it will be always there whenever you have some electrons so flowing from somewhere, and or formation of a bond. Formation of a bond. electron doesn't jump from atom to atom. Okay, from atom to atom. So it should be something related to bond. Either a bond should be formation of bond should be taking place, or there should be a breaking of bond. Done, guys?
Done, sir.
Right question. Draw curly arrow for the following. Okay, so number one, let us say you have CH3 Br and it is forming CH3 positive plus Br negative. Okay, plus Br negative. So what do you think? What is happening here? The curly arrow should be, where should be the tail? Where should be the tail of curly arrow, guys? The tail of curly arrow should be at what? Like this, and it should be somewhere like this, right? So this is the tail. Yes, tell me. Reba, what did you say? Yes, Reba? I could not hear you. There are three things, na? Abhinav, Najib, Surat. Okay, Surat has to abhi abhi aayi, Reba. See, there are three things, okay, in the reactant. We have a carbon atom, we have the bond, and we have the bromine atom, right? Three things. So you have to tell me, where should the tail be of the curly arrow? The electrons are flowing from where to where? It is going from 1 to 2, 2 to 3, or some 2 to 3 to 1, or where? Where is the flow of electron happening? You look at the reactant and you look at the products and try to think about it. Yes, Acha, can somebody please speak? Abhinav, can you speak? No. Reba, what happened, guys? Najib, am I not audible? Can you hear me, guys? Are you there? Should I stop the class? Huh? Nothing in the chat also. Reba, I can't hear you. Can you write in the chat anything? What are you saying? So can you tell me the answer? Do you know the answer, Reba?
On BR?
Yeah, what did you say?
On BR.
No, I'm asking about the tail, no? So tail will originate from where? So this tail will be?
Middle?
Sorry, middle. That means the bond, right? Single bond,
Yes,
okay?
sir. Yes, sir.
So tail will be always at an electron source. Like this, right?
Yes, sir.
Okay, now let me show you another example. If you have CH3 and Mg. Now, in this case, I gave you the products. I will not give you the products right now, okay? Now you have to tell me, there is a bond between carbon and magnesium. So generally, we will not be using hydrogen. We will not be breaking the CH bond. There will be some cases in which we will be breaking. But as of now, we can see that the most loose bond, that means the most weak bond, the weakest bond here is the CMG bond, right? Because carbon and hydrogen, they have stronger bonds. So we will be breaking carbon hydrogen bond on some extreme cases, not very commonly. Okay, we will not be breaking the carbon hydrogen bond very commonly. So in this case, you tell me which is more electronegative, carbon or magnesium? Which is more electronegative?
Carbon?
Carbon is more electronegative, right? So in this case, what will happen? The tail will be again in the single bond, and the electron will go to the CH3 carbon atom. We'll get a lone pair electron, and that is why a negative charge plus Mg will get a positive charge. Correct?
Yes.
Okay. Now this is just an example. Okay, so just an example. Yeah, regularly you will be having something like MgBr here. Okay, so Mg, and let me write Mg plus, because Mg is too positive now. So MgBr, and there will be a positive charge here. So let me write a few more things, and then you tell me, you write in your notebook. CH3 SH, how the bonds will be breaking. CH3 done, guys. Yes, Reba, Abhinav, guys, done. Oh, yes or no? Can you please tell me that? Huh? Yes, Reba, are you there? What happened? Reba, Abhinav, Mohammed Sheikh is also, but लेकिन ये लोग तो रहते ही नहीं है.
Yes, sir.
Done. Yes, sir. बोल रहे हैं ऐसे जैसे Are you not hearing me? What am I asking? Huh? Done or not? I'm asking this now. Are you done with these three?
Done, sir.
So tell me. See, I will stop giving questions now, because if you take so much of time and you don't even, you guys don't even speak, huh? What is the use? Surat, are you there? So yes, tell me, in this question, the electron will be getting transferred from, which will get the electron, the carbon or the sulfur?
Sulfur.
Sulfur will get the electron. Okay, so you will show the arrow pushing like this. Now here, tell me, carbon or oxygen, which will get the electron?
Oxygen.
Oxygen will get the electron. Okay, so see here what will be happening. CS3 positive plus SH negative. In this case, what will be happening? CS3 positive, and see the oxygen, what will happen? It will reduce the formal charge. Okay, so what will happen? It will be getting reduced. So electron is oxygen is getting electron, so positive charge will be removed and it will be having H2O only. Okay, it will be having H2O only. Here the Cn negative will be getting the Cn negative. Okay, fine. Now we have given you some introduction about the electrophiles and the nucleophiles. Okay, we will be revisiting electrophiles and nucleophiles a bit later. Right now, let us see, and let me ask you a question, and that will be the basis of our next class. Okay, basis of our next class. Whenever we do some reaction, okay, for example, we had essentially this reaction. Initially we said that there is a CBr bond and we are reacting this with NaOH in aqueous phase, that means in water. And what is happening? We are forming COH plus NaBr, COH plus NaBr. So what would have happened is that there will be this bond, the CBr bond, and this sodium will be like this, Na plus, because it is an aqueous solution, and OH negative will be here like this. Okay, and we know that this bond is what? It is delta negative, this is delta positive, right? So hence we can see that this particular carbon atom, it is what? Electrophile. That means it has a positive charge, so it will attract the OH negative. It will attract the OH negative. Now OH negative will come with the electron pair. Now this carbon, it already has this, CS3, right? And there will be one hydrogen here also. Now it already has 8 electrons. That means it is completely filled, but still it will be attracting OH negative because of the positive charge, delta positive charge. Now, when the OH is coming with its electron, the carbon, it cannot accommodate 5 pairs. So what it will do, it will slowly give out the electron pair to Br negative. So essentially we will be forming a positive charge on the carbon atom. Now simply OH negative, it will reach here, and what it will do, it will make a bond with, like this. Better representation will be this, like this, with the carbon atom. Okay, so we have formed a charged species, right? A charged species, that is a carbocation. So generally, this is the reaction, how reaction happens. We will be having these carbocations. These are known as intermediates. So we have reactant, okay, and products. This is the way we have been seeing chemistry. This is the way we have been seeing chemistry. In organic chemistry, we use some different terms. In the reactants, we say that there are two things. There is substrate. Substrate, what is substrate? The organic molecule. Organic molecule. Okay, this is the substrate. Plus a reagent. Okay. What is a reagent? The reagent is something that initiates the reaction. Okay, and it is more unstable. Reagent is more unstable. It is sometimes organic. It can be sometimes inorganic also. Okay, mostly it is inorganic. Then we form some intermediate. Okay, then we form some intermediate. Okay, now this step is most crucial. Okay, this step is most crucial. Most crucial. Why? Now the intermediate, it is formed by breaking of bonds, right? It's formed by breaking of bonds. Now we can say that there is three types of species that can be formed. There can be A positive, which will be formed. There can be some A negative, or there will be some A free radical. These are the only three species which can be present in the intermediate. There can be some other species also, but that is not the scope of the syllabus. So we will be looking at simple molecules which have positive charge, a negative charge, or a free radical. Okay. Now, intermediates are formed by breaking of bonds. Breaking of bond, it requires energy. That is why this is the most crucial step. Now, when you have charged species, then they can easily combine and they can easily form products. Okay, they can easily form products. Okay, they can easily form products. Now, you guys should answer me. Okay, essentially only Reba answers. So Reba, you tell me, for a reaction to be fast, the intermediate. Let me ask you one more question rather than this. For a reaction to be fast, the step involving breaking of bonds should be fast or slow? Tell me. If I want a reaction to be fast, then what should happen? The step involving breaking of bonds should be fast or slow? This step, reactant to intermediate. Yes, Reba. It should be slow. Why? No, I'm not asking. Now, I'm not asking how will it be, how it should be. Like if you want a reaction to be fast, then if it is slow, then why the reaction will be fast? Reba, you understand why it should be fast?
Yes, sir.
Okay. अच्छा तो आप बस ऐसे उल्टा जवाब देने के लिए स्लो बोल रही थी क्या? नॉन इंट्यूटिव. Okay. Listen, if this particular reaction is going to be fast, then relatively speaking, this reaction, I can say that this reaction can be fast. The rate of this reaction will be directly proportional to the stability of intermediate. Yes or no? Because
yes, sir.
if my intermediate is what? It is stable. That means this reaction can happen more easily and more fastly with lesser amount of energy. And if this reaction is happening more fastly, then our complete reaction, okay, complete reaction means reactant to product, it will be also more fast. And hence we can say the rate of reaction is proportional to the rate of formation of intermediate, and this rate of formation of intermediate, it is directly proportional to the stability of intermediate. So rather we are not, so we can directly see the structure. Now with structure, we will see the stability of intermediate, and then we can predict the rate of a reaction. Okay, so hence we will directly use this simplified notion of rate of reaction is directly proportional to the stability of intermediate. Okay, stability of intermediate. Okay, rate of reaction is directly proportional to the stability of intermediate. Write this down. We have seen three types of intermediate. Okay, we'll be looking at carbocation. Okay, we'll be looking at carbon ion. We'll be looking at free radical. Carbocation, that means a carbon with 3 bonds and a positive charge. Carbon ion, carbon with a 3 bond and a negative charge. Okay, that means it has an extra pair of electrons. It has how many electrons? It has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay, it has 8 electrons. Now 8 electrons, but the carbon it has 8 electrons. It's 1, 2, 3, 4, 5, 6, 4, 5, 6. Yeah, 8 electrons. Now the carbon's electrons are 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5. So 5 are the valence electron, but essentially carbon neutral, it should have 4 valence electron. So in this case, carbon is having 5 valence electron, but there are in total 8 electrons. So this is what this is electron rich. Okay, and free radical, in this we will be having, this carbon is also unstable. Okay, all of these intermediates, all these intermediates are what? Unstable. This is electron poor, right? This is electron rich, and this is what? This is free radical, which is electron poor. Okay, so we have 3 types of intermediates in which carbocation and free radical, which are similar, and carbon ion, it has more electrons. It has more electrons, and all of these two are what? These two are essentially, these two are charged species. These two are charged species. Okay, write this down. Let me know if you're done. Done, guys? Yes, Reba, done?
Done, sir.
Okay. Next is, we have seen an IUPAC nomenclature. You have seen an IUPAC nomenclature that organic molecules, these are made up of carbon, hydrogen. There are functional groups, right? There are functional group, and then there are substituents. Okay, substituents. Now, how does these functional group and substituent, these affect the intermediates that we have been looking? Okay, so how does the functional group and intermediate substituents affect stability of the intermediates? Okay, stability of intermediates. Mainly, we have to answer this question. Okay, now to answer this question, so stability of intermediates, that means what? One thing that we have learned earlier is that higher charge means higher charge density is bad, na? It means low stability. Okay, that means we want to see how the functional group and the substituent, they are affecting the charge density. They are affecting the charge density of the intermediate Okay, so for example, let me take an example of carbon, and it has only hydrogens. Okay, it has only hydrogens, and there is a negative charge here. There's a negative charge here. Okay, what would have happened here? Now, in this case, the hydrogens, okay, the hydrogens, they are bonded with carbon with a sigma bond, So there is electron pair. There is electron pair sharing. Now we also know that the carbon and hydrogen, they have similar type of electronegativity, and essentially more carbon is more electronegative than hydrogen. Now, this case, and if I have something like carbon, which is attached with fluorine, and fluorine, there are 3 fluorine atoms, and there is a negative charge here. Now, this carbon atom, it is what? It is having some more electrons. Okay, it is having more electrons in both of these cases. Both of these cases are the carbon is negatively charged, and the carbon is here also negatively charged. But in this case, what would have happened? In the CF3 case, the electron pairs now, the electrons pair, this would have been attracted. So the carbon will have less electron pair towards itself. Fluorine will be attracting the electrons from carbon. And if fluorine is attracting the electrons from carbon, the charge density would decrease. And because what is electronegativity? Pulling of electron. So charge density decreases. Initially, if I just look at carbon negative, that means all the charges on carbon negative. But if fluorines are attached to carbon atom, then the fluorine will be pulling the electrons and it will be decreasing the charge density. If the charge density decreases, the stability increases. Right? Stability increases. Now, this is an effect. This is an effect of fluorine. Similarly, what we will be doing, we will be generalizing these things, and then we will be talking about different groups and atoms when they are combined with a particular. No, essentially, what we need to do is to look at the electron displacement effect, and how the electrons are displaced by the effect of different substituents, or functional group. So what did we start with? How functional group or substituent affect the stability of intermediate? We obviously know that CS3 negative and CF3 negatives are not similar. Will there be any effect of the fluorine negative? Next, we saw that if the charge density, if they are affecting the charge density, and that means they are lowering the stability. And in the example, what we saw that they are affecting the charge density. They're affecting the charge density by movement of electron, right? By movement of electron or displacement of electron. What is happening in fluorine? Fluorine is displacing the electrons away from carbon atom. That is why the charge density is decreasing, right? By the movement of electron or displacement of electron, right? By the displacement of electron. Now, let us say if I attach this carbon, which has a negative charge, with some groups, okay, with some group which are giving carbon some electrons, okay? These are giving carbon some electrons. Then what will happen? The charge density, the Q density of carbon, this negative charge, it will increase, and the stability, it will decrease. So essentially what we need to learn is the displacement of electron, okay? Displacement of electron. So we have next topic, that is electron displacement effects. Electron displacement. Electron displacement effects, okay? So this will be the topic of our next class, that is on Sunday. So please remember how we started. We started with the reaction, and we said that the reaction always, they will start with some bonds which break, okay? Bonds break, okay? And if the bonds break, they form intermediates.